Hey everyone, welcome back to another past paper video for CIE A Level Maths. Today we're going to talk about the paper 4, which is Mechanics 4.1 variant from the October-November 2024 series. So let's jump into the paper. Question number 1. Two particles of masses 1.8 kg and 1.2 kg are connected by a light inextensible string that passes over a fixed smooth pulley. The particles hang vertically. System is released from rest. Find the magnitude of the acceleration of the particles and find the tension in the string. Right, okay. Since we need, let's say for example, this is pulley, and from this are hanging two objects. Let's call them A and B, whatever they are. So one weighs 1.8 kg, so 1.8 g will be the weight, and the other one will be 1.2 g weight. The tension, since it is a single string, the tension would be the same, and the acceleration would be this way because this is heavier. Right. So we make two equations for this. You have 1.8 g minus t equals to 1.8 a. The other one, the other object is actually moving this way, so you have t minus 1.2 g equals to 1.2 a. Sorry, 1.2a. Now we can solve this simultaneously. So as you can see, we do not need to subtract the equations, we just simply need to add them. So 1.8 minus 1.2 is 0.6 g equals to 1.8 plus 1.2, that is going to be 3. Yeah. So 3a, so 0.6 g, so a would be 0.6 times by 10 meters per second squared divided by 3, so 6 divided by 3, 2 meters per second squared. So now we need t, so therefore t would be 1.2a plus 1.2 g. So 1.2 times by 2 plus 1.2 times by 10. So that would be 2.4 plus 12. So that is 14.4 newtons. And that's about it. So you can write the final answer as t is equal to 14.4 newtons and acceleration is 2 meters per second squared. So straightforward, simple answer. Let's move on to the next question. Question number 2. A particle of mass 7.5 kg starting from rest at A slides down an inclined plane AB. The point B is 12.5 meters vertically below the level of A as shown in the diagram. Given that the plane is smooth, use an energy method to find the speed of the particle at B. Okay, so smooth means no friction. That means no work done against friction. And it's starting from rest, so that means U is 0. Now, we know how the energy method would go, but if you have forgotten that, you can just quickly make the equations for that. This is weight, mg. If this is theta, this will be the mg sine theta component towards or along the plane. So the only force F is equal to ma you will have would be mg sine theta equals to ma. Now if you multiply this by the distance covered, right? So distance covered, let's call it AB. So mg sine theta times by AB. Now we need to make this side in terms of v and u and s. So acceleration can be v squared minus u squared over 2s. So it can be written as v squared minus u squared over 2ab, because that's the displacement, and then times by AB. So AB on the right hand side gets cancelled out. You're left with AB sine theta, which is actually just 12.5 weight. So this is mg delta H, change in potential energy, is equal to change in kinetic energy. So that's what we just have to use over here. So loss of gravitational potential energy equals to gain in kinetic energy. So mg delta H is equal to half mv squared, and we don't need u squared because this is already 0. The mass and mass gets cancelled. This is 10 times by 12.5 equals to half times by v squared. So we can actually solve this. Oh, sorry, we ran out of space. So therefore v squared would be 2 times by 10 times by 12.5, sorry, 12.5, 250. So which would be square root of 250 5 square root 10, or 15.8. You can also add 1 over here, but 3 significant figure would be fine. It is given instead that the plane is rough and the particle reaches B with a speed of 8 meters per second. The plane is 25 meters long and constant frictional force has magnitude Fn, F newtons, and find the value of F. So you see, this time there's going to be a friction also. So there's right over here on this side, on the left hand side, the loss of gravitational potential energy is not just simply equal to gain in kinetic energy, but it will also be equal to work against F. So basically we don't actually have to write it over here, we need to write over here. So so change in gravitational potential energy equals to change in kinetic energy plus work done against friction. Okay, so change in EP is equal to change in EK plus work done against friction, let's call it. So what this basically means is that the total change in potential energy is not resulting in a total change in kinetic energy, but it is also resulting in some energy lost against friction. So AB now is 25 meters, so basically almost the same thing. So mg delta H and equals to EK, change in kinetic energy, half m v squared minus u squared plus F times by AB. So let's plug in the values. Delta H is same as before, 12.5 actually. times by mg. Now we will need the mass also, 7.5 times by 10 equals to half times by 7.5, and now v squared they gave us was 8 meters per second plus force times by, or friction times by 25. So we simplify both sides now. 12.5 times by 75, that is this, minus 0.5 times by 7.5 times by 64. So F times by 25 is 697.5. So therefore F would be 697.5 divided by 25, 27.9 newtons. Right, okay, and that's it for this question. Let's move on to question number 3. Coplanar forces of magnitudes 52 Newton, 39 Newton, and p Newton act at a point in directions shown in the diagram. System is in equilibrium. Find the values of p and q. So if the system is in equilibrium, that means the sum of forces parallel to 52 newtons, let's call it y-axis, parallel to y are equal, and the sum of forces parallel to x, or 39 newtons, are equal. So basically what we can do first is we can resolve p into forces parallel to 52 and 39. So this would be p cos of theta, and this would be p sine of theta. Right. Another way we could do this is using the triangle method. So you have 52, let's go to 39 over here, (39), 52, and this is your p. Right. So this is your theta that we need to find out, and we know that the angle between 52 Newton force and 39 Newton force is 90 degrees. So let's try both methods. Both of them have their pros and cons. So let's try the resolved one. So sum of forces in y, you have 52 minus p sine theta equals to 0, which means that p sine theta is 52. Similarly, sum of forces in x is 39 minus p cos theta equal to 0. Therefore, that means that p cos theta is 39. So we need p and theta, so we make it this way: p sine theta over p cos theta. You get 52 over 39. So p and p get cancelled, so that becomes tan theta equals to 52 over 39. So therefore theta would be tan inverse of 52 divided by 39, 53.1 degrees. Now theta is this. Now we can use this value to find out p. So p would be equals to 52 over sine of theta. So this is the exact value. So exact value of the angle is the tan inverse. So 52 over sine of tan inverse of 52 over 39. So since we have it in the calculator, 52 divided by sine of answer, that is 65. Now let's see whether we get the same answer from the triangle method. Actually we would have to use the cosine rule or the sine rule over here. So let's say this is alpha, and technically this would be theta, right, because the parallel angles, so we have actually both of them in them. So since this is Pythagoras theorem, actually we could have found theta using, we could have found P using Pythagoras also. So sum of forces in x whole squared plus sum of forces in y whole squared also, because we had actually summed up both of them. And anyways, you can see this over here that you were getting the same thing. The P squared is equal to 52 squared plus 39 squared. This would get us P to be equal to 52 squared plus 39 squared, 65 newtons. And now we can find out this. We have the value 52, 39, and this is opposite to that. So tan theta equals to 52 over 39, and as you can see, it would get you the same value as before, would be 53.1 degrees. Two methods, both of them equally powerful. Right, so therefore P is equal to 65 newtons and theta to be 53.1 degrees. And that's it for this question. Question number 4. A bus travels between two stops A and B. The bus starts from rest at A and accelerates at a constant rate of A meters per second squared until it reaches a speed of 16 meters per second. It then travels at this constant speed before decelerating at a constant rate of 0.75 A. Okay, so A and 0.75. Coming to rest at B, the total time for the journey is 240 seconds. Okay, alright. Sketch the velocity time graph for the bus's journey from A to B. Okay, so the acceleration is greater. That means it's steeper. And the deceleration would be slightly longer because it is 0.75, 75% of that. That means it will take longer to come to rest. So this is your 16 meters per second, and this is your 240. This can be your 0. Yeah, basically this is it. Find an expression in terms of A for the length of time that the bus is traveling with constant speed. So basically they are asking for this time. So let's say between T capital 1, capital 2. So T2 minus T1, that's what they're asking. The total journey is 240. So we can use simple interpolation or linear interpolation or straight line relationships, or we can use V is equal to U plus AT relationship also, depending on how you want that. So the gradient between these two is A, and gradient between these two is minus 0.75A. So we can use simple gradient relationship, which is in short the same thing that we are talking about. So A is rise over run, basically T1 minus 0, 16 minus 0, so 16 over T1. So T1 is 16 over A. Now for the second one, minus 0.75A, change in velocity is minus 16, right? So simply going down, and we need to find out what the run is. So which would be 240 minus T2. We don't need the actual value at the moment, we just need to know what the time duration for this is. So AA get cancelled, you get 240 minus T2 equals to 16 over 0.75A, which can be rewritten as, since 0.75 is 3 over 4, 3 can be left down, 4 multiplied with, so 64 over 3A. Now this is 240 minus T2. So T2 minus T1 therefore would be a T2 would be 240 minus 64 over 3a. You see, just simple rearranging of this. T2 240 minus this thing, and then minus T1 is 16 over a. So we can do is make times by 3 times by 3. 64 minus 48 is 16 itself. So 240. No, 64 plus 48. So 64 plus 48 because minus minus of 112 over 3a. So this is the time duration between during the constant speed phase. You can actually make it this way also. So 240 times by 3 would be 72. Yeah, 720 minus 112. Sorry, 720a minus this divided by 3a. We can also make it this way. Right, given that the distance from A to B is 3000 meters, find the value of A. Okay, so the total distance is now the area under the total graph. So 3000 half times by 16 times by T1 plus 16 times by the time, which is 720a minus 112 over 3a plus half times by 16 times by 240 minus T2, which we actually figured out to be 64 over 3a. 64 over 3a. T1 was 16 over a. Yeah, 16 over a. Right. So, what do we have over here? We have a in the denominator, we have 2 in the denominator. Okay, so let's first simplify all of this together. Okay, so 16 times by 16 divided by 2 is 128 over a plus 16 times by 720, 11520, a minus 16 times by 112, 1792, 3a, and plus, oh wait, okay, 0.5 times by 16 times by 64 divided by 3, 512 over 3. Okay, so the only one that does not have a at 3 is this one. So we can multiply this and equals to 3000. Now we can multiply 3a on the other side, so this would become 9000a equals to 128 times by 3, 384 plus 11520a minus 1792 plus 512. Oh, okay. We take everything on one side, so this a minus 9000a, and then 1792 minus 512 minus 384. So 11520 minus 9000, 2520 A, and 1792 minus 512 minus 384 is 896. So A would be 896 divided by 2520. So 16/45 meters per second square. Right. Okay, so this is this question number 4. On to the next question, number 5. Question number 5. A particle A is projected vertically upwards from point O with a speed of 80 meters per second. 1 second later, a second particle B with the same mass as A is projected vertically upwards from O with a speed of 100 meters per second. Okay. At time t seconds after the first particle is projected, two particles collide and coalesce to form a particle C. Show that t is 3.5. Right, okay. So displacement of A would be equal to displacement of B, so that is ut plus half at squared. So u is 80 t minus half plus half times by minus 10, because A is minus g, and t squared. So this would be 80 t minus 5 t squared. Displacement of B would be ut plus half 8t squared, 100 t minus 1 because it's projected 1 second later, plus half minus 10 t minus 1 whole square. So this would be, can be simplified as 100t minus 100 minus 5. This is minus 5t squared minus 2t plus 1, so minus 5t squared plus 10t minus 5. So let's simplify this. So you have minus 5t squared plus 110t and minus 105. Right. Now displacement of A is equal to displacement of B at that point. So 80t minus 5t squared equals to minus 5t squared plus 110t minus 105. So minus 5t squared minus 5t squared, 110t minus 80t equals to 105. So basically t equals to 105 divided by 30. So 105 divided by 30 is 7/2, which is 3.5 as shown. Right, okay. Find the height above O at which particles collide. Okay, so this is the time, so we need to see at the height. Basically, first we find out the displacement. So S is equal to 80t minus 5t squared. So 80 times by 3.5 minus 5 times by 3.5 squared. So 80 times by 3.5 minus 5 times by 3.5 squared, 875/4, or you can also write it as 218.75 meters. Right, okay. Find the time from A being projected until C returns to 0. Until C returns to 0. So basically we need to figure out what velocity C has when it's first created. When C is created or is made from A and B. So basically we need to use the principle of conservation of momentum. So MA/UA plus MB/UB. Wait, what are these particles called? Yeah, A and B, right. So this becomes MC/VC. Do we know the masses? They are identical. Same masses, right? And right, if they're merging together, so that will be double the mass. Okay. Do we know the velocity at time t? Okay, so we need to figure out what the velocity at time t is. So UA at t, 80 minus g times by 3.5, 80 minus 35, and that would mean 76.5, and UB at t would be 100 minus 10 times by, this is t minus 1, so 2.5, so 100 minus 25, 75. Right, okay. So masses are the same, so m times by 76.5 plus m times by 75 . Oh, no, 80 minus 35, sorry. 45, sorry. 45. So this is 45. Okay, alright. Equals to 2m VC. So m gets cancelled. So VC is basically 45 plus 75. So 120 divided by 2. So that is 60 meters per second. So this is the velocity with which it starts upwards. Okay, so this is the velocity, initial velocity of C. So initial velocity of C at t is equal to 3.5 seconds is equal to 60 meters per second, and this is upwards, right? And right, we need, okay, so for this thing, okay, so we need to know when it returns to O, and so the displacement it covers is this, so that is going to be negative net displacement minus 218.75. So S is equal to UT plus half AT squared. So S is minus 218.75 equals to UT is now 60T minus half of 10 T squared. So you have minus 218.75, 60T minus 5T squared. So it can become 5T squared minus 60T minus 218.75 equal to 0. We need to solve for T. 60 plus minus 60 squared, 3600 minus 4AC. So minus 4 times by 5 times by minus 2, 18.75, that is 4375 divided by 2a, 10. So we have 60 plus square root of 3600 plus 4375 divided by 10. So one answer is 14.93. The other answer would be negative minus 2 and 9, so obviously that can't be correct. So therefore this is the time. So total time would be, we need to add the 3.5 on top of it, so 14.93. So 14.93 plus 3.5, that is 18.43. So we can say 18.4 seconds. Right, okay, moving on. A particle of mass 1.2 kg is placed on a rough plane which is inclined at an angle theta to the horizontal, where sine theta is 7/25. The particle is kept in equilibrium by a horizontal force of magnitude P Newton acting in a vertical plane containing a line of greatest slope. The coefficient of friction between the particle and the plane is 0.15. Find the least possible value of P. Now let's first off resolve the forces and find out what the normal reaction force is. So this is our mg. This will be mg cos theta. This would be normal reaction force. And this would be mg sine theta. So first let's figure out what would be R. So, we have to resolve the P also. So P would be R. Okay, let's do this here. So P is going to be P, same angle, right? So P sine theta, and this would be P cos theta, right? Okay. Sine theta is 7/25, which means from the right angle's perspective, this is perpendicular, this is hypotenuse. So 25 squared minus 7 squared, 24. So cos theta would be 24/25. Right, okay. So first off, R is equal to P sine theta plus mg cos theta. So P sine theta is 7/25 and mg is 12, cos theta is 24/25. So we can write it as 7p plus 12 times by 24, 288 over 25. So your F is equal to mu r, mu r would be written as 0.15 times by 7p plus 288/25. We'll see what the value becomes. So 0.15 divided by 25 is 3/500. So either we will figure this out later on. Right. Okay. So now the question of which direction of motion should we take? Because if we take motion to be in this direction, friction would be in this direction. So that would mean P is holding P is against friction and mg sine theta. So it would give us the maximum value of P. We need the minimum value, so we would need P to be in this, the motion to be in this direction. So friction can be in this direction. So when friction is in this direction, then P can be minimum. So you have mg sine theta minus P cos theta minus friction is equal to, you see now this is in equilibrium, so 0. So mg is 12, sine theta is 7 over 25. P is P cos theta would be um, 24 over 25, and F is this thing. Now this would be the maximum value of F. Only when we use the maximum value of F we would get the minimum value of P. However, let's see what we can get anyway. So when we have this, you see, if we rearrange this to make P cos theta the subject, so you have P cos theta equals to mg sine theta minus F. P 24 over 25 equals to 12 times by 7 over 25 minus F. Minimum value of P will actually come from maximum value of F. So we will use maximum value. So 12 times by 7 over 25 minus this thing, 0.15, 7P plus 288 over 25. On both sides you have 25, 25, 25, so basically you have 24P equals to 12 times by 7, 84, minus 0.15 times by 7, 1.05 E minus 0.15 times by 288, 43.2. So 24 plus 1.05, 25.05. P equals to 84 minus 43.2, 40.8. P would be equal to 40.8 divided by 25.05. That is equal to 272.167, 1.63. Right, and this is this value. Let's move on to question number 7. Question number 7. A car has mass 1200 kg. When the car is traveling at a speed of v meters per second, there is a resistive force of magnitude kV newtons. Maximum power of the car's engine is this. The car travels along a straight level road. The car has greatest possible constant speed of 48 meters per second. Okay, so remember this, that the greatest possible constant speed can only come from greatest possible power of the engine. So the maximum speed can only come from maximum resistance, because when your driving force is maximum and is able to maximize the resistance, maximize the work done against the resistive force, then you have the maximum speed. So power is equal to FV. that is 92,160 equals to kV newtons, K V times by V. So K would be 92,160 squared. So 92,160 divided by 48 squared is 40. Therefore, it's easy to show. At an instant when its speed is 45 meters per second, find the greatest possible acceleration of the car. So, the driving force, that means the driving force D, resistive force R. So D minus R is equal to MA. So D is, wait a second. Okay, greatest possible. Okay, so D is the force. We need to figure out what the force is. That will be, again, power is equal to FV, so we will do power 92,160 divided by 45 minus the resistive force K, 40 times by 45 equals to mass, which is given as 1200 A. So 92,160 divided by 45 minus 40 times by 45, 248, 1200 A. So A would be 248 divided by 1200. The acceleration maximum would be 2.07 or 31 over 150. Okay, and the car now travels at a constant speed up a hill inclined at an angle of sine inverse of 0.15 to the horizontal. Find the greatest possible speed of the car going up the hill. So basically we would do the same thing over here, that the driving force now, let's call it D, the resistive force, there's a component of weight also now, so mg sine theta and plus r. So d minus mg sine theta minus r equal to 0 at a constant speed, right? Now the force D is again 92,160 divided by V minus mg, that is going to be 12,000, and sine theta is this. So angle is equal to sine inverse of 0.15. Therefore sine theta would be 0.15. So 12,000 0.15 minus R would be kV, 40V equal to 0. So thrown on the other side, so multiply by V on both sides, so 92,160 minus 12,000 times by 0.15, 1800 V minus 40V squared equal to 0. This has now become a quadratic equation, so 1800 divided by 40, 45, and let's hope 92,160 divided by 40, 2304 minus V squared, V equal to 0. So now this is a quadratic equation. We can rewrite it as this, minus 2304 equal to 0. Okay, v would be equal to minus 45 plus minus 45 squared minus 4 times by 2304 square root divided by 2. The one value would be minus 45 plus square root of 45 squared minus 4 times by plus divided by 2. So one value is 30.5. The other value would be minus 75.5. So therefore we will select this one. So therefore speed is 30.5 meters per second. Question number 8. A particle P moves in a straight line passing through a point O with velocity 4.2 meters per second. At time t seconds after P passes O, acceleration A of P is given by this. Find the distance P travels between the times at which it is at instantaneous rest. So instantaneous rest means where velocity is 0 momentarily. So let's integrate this. So v would be integral of a dt. So you have integral of 0.6 t minus 12.7 dt. So we will get 0.6 t squared over 2 minus 2.7 t plus c. So initial when t is equal to 0. So at t equals to 0, v is 4.2. So 4.2 equals to c basically. So therefore v would be 0.3 t squared minus 2.7 plus t plus 4.2. Now this is a quadratic equation, right? This is a quadratic equation. It will have some roots. Now we need to figure out what's the distance P travels between the times at which it is instantaneous rest. So basically we need to figure out the area under the graph between its roots. So we need to figure out where it's 0. So all of these are divisible by like 3. So we multiply this by 10. We get 3 t squared minus 27t plus 42 equal to 0. Then t squared minus 9t and 42 divided by 3, 40. So 2 and 7 basically will give us 14. So t minus 2, t minus 7 equal to 0. So one value is 2, one value is 7. So distance between t is equal to 2 and t is equal to 7. Remember, it's area below the graph, below the x-axis, so it's supposed to come out to be negative. So we will area under graph and time axis, t-axis. Area, you can also say area between the graph. Oh, right. So between 2 to 7, 0.3 t squared minus 2.7 t plus 4.2 dt. You can actually put a minus sign, or you could reverse the limits also. So you can actually do 2 and 7 instead. because we're actually going to get a negative answer if we do 7 and 2. So we have 0.3 t cubed over 3 minus 2.7 t squared over 2 plus 4.2 t from 2 to 7. 0.3 divided by 3 is just 0.1, so 0.1 t cubed minus 2.7 divided by 2, 1.35, t squared plus 4.2 t to 7. That is now going to be 0.18 minus 1.35, 4.22 minus 0.17 cubed, I think 7 cubed is 2, yeah, 343. 343 minus 1.35, 49 minus plus 4.2, 7. Now we just need that, so 0.1 times by 8 minus 1.35 times by 4 plus 4.2 times by 2, 19 over 5 minus 0.1 times by 343 minus 1.35 times by 49 plus 4.2 times by 7, which is this value. So minus 49 over 20. So we get 19 divided by 5 plus 49 divided by 20. We get 25 over 4 or equal to 6.25. So that is the displacement covered. So hence S is either 25 over 4 meters or 6.25 meters. And I think that is the end of this. Yes, alright, so that is the end of this paper. Hope you enjoyed the working and explanations. If you have any further questions, feel free to reach out in the comments. If you have any doubts or if you would like to us to do a specific paper, also please, I would love to hear from you in the comments, or you can reach us out through the link tree. Any method of communication is fine, WhatsApp, email, whatever. If you like this video, give it a thumbs up, subscribe to our channel, and turn on the notifications for future paper updates. Meanwhile, take care. We will see you in the next video. Bye bye. Take care.